Okay, now coming back to our screen, what we can see here is the recorded high and the recorded low. Okay, coming down here, we saw our temperatures, I believe, how it varies across different locations. So, starting with the humidity, you have something known as the absolute humidity. It is very simple. In the air, you have moisture. Moisture is present in your air. So, how much moisture is there per unit weight or per unit volume of your air? So, you measure it in grams per kg or grams per meter cube. Any confusion with the absolute humidity? Any questions here? Eman, any questions?
No, sir.
No, sir. Okay. So absolute humidity, it is the absolute value. I think it is also known as the specific humidity. What next is the relative humidity. It is how much water vapor or moisture is actually contained in the air to the maximum amount that air can hold before condensation starts. You have a certain say this is your air and there are certain particles of water which are present. Okay, is this scribbling visible to you guys?
Yes.
Yes,
Yeah.
sir.
Okay. And so how much more moisture can I bring in before this air, this outer one, will not be able to hold this moisture and it will fall? That is the condensation. How much more I can bring in? This humidity thing, can you tell me, you guys have studied chemistry not long back, right? Physical chemistry? Yes?
Yes, sir.
I never liked chemistry to a large extent, but this thing I find it a good thing. How much moisture can it hold? On what will this value, this absolute humidity, how much moisture your air can hold, on what parameters will this value depend? Can you tell me?
The temperature,
Temperature, yes.
volume,
Precipitation.
Sorry?
Air
volume,
Or precipitation.
Precipitation is what is going to take place.
So like if there is okay. Sir.
sir, atmospheric pressure.
Sir, if there
Okay,
is
who
more
said
rainfall,
temperature
Sir,
here?
air
more
movement.
humidity.
Huh?
Sir, location, sir,
Air
location.
movement.
Location is,
pressure,
okay, pressure, yes, pressure.
Sorry, pressure.
The atmospheric
Temperature,
pressure is
pressure,
also
altitude, air movement.
sorry?
Temperature, pressure, altitude, air movement.
Okay, temperature, pressure, altitude is something which I believe Gomti is trying to talk about. Location, and what was the last one?
Movement of air.
Air movement. Okay, wind. I'll keep it for the time being as wind. These four criteria. Let's just look at this temperature. Who said temperature first? Which girl said it?
me, Nitisha.
Nitisha. Now tell me, if I increase the temperature, will it be able to hold more moisture? If I reduce the temperature, then it will be able to hold more moisture.
If we increase the temperature, it will be able to hold more moisture.
Okay. So if I increase the temperature, this volume will increase, right? What it was earlier, that volume would increase, so it can hold in more amount of moisture. So relative humidity is somewhere very much linked with this temperature. So earlier, I'll just try to scribble a little bit more. If this is my one volume of air and this is my another volume of air, and I'll take blue for the purpose of my water. So there it holds two droplets of water. Here the relative humidity is say 20%. These two same droplets in this case, okay, is now how much? Is now going to be say 10%. The relative humidity has now come down. Yes or no? Clear?
Yes, sir.
Clear to all of you?
Yes, sir.
You're getting it here. Earlier, when the volume was low, and when I've increased the volume, the relative humidity is definitely going to come down.
Yes,
And
sir.
got it. And on the other side, if I reduce the size of my air volume, or that is going to be affected by the temperature, and I bring in the same water, probably now my RH is equal to say how much?
60.
80, 60, maybe even nearing 100 now. So my relative humidity has increased. So in the last I mean, if this was the T, here the T has increased. And in this case, the T has decreased. The temperature has decreased, and therefore there is a high chance that condensation may start occurring. Clear? Abhishek Chaudhary?
Yes, sir.
Clear?
Yes, sir.
Okay, till now I believe up to this point we have been able to understand what we are targeting. Aman Singh, clear? Aman,
Yes, sir.
got it?
Clear.
Okay, let's
Yes,
proceed
sir.
now to what I have next. So this relative humidity, it is always relative to a temperature. So the corresponding dBT is always necessary. So relative humidity is equal to absolute humidity by the saturated humidity into 100%. Whenever they tell you the temperature in the news, they generally tell you the dBT and the relative humidity. Okay.
Sir, what is SH in the formula?
Saturated humidity.
Okay, sir.
What is the maximum it can hold? We figured out. And what is the minimum? What is at present the absolute humidity? Got it? So the wet bulb temperature is something that is measured so as to determine the value of the humidity. There is something known as the psychometric chart, psychrometric chart. We'll be looking into it when we discuss about the thermal comfort levels. Okay, for the time being, just remember there is something known as the psychrometric chart, and we'll see to it. So this wet bulb temperature, it is the temperature read by a thermometer in which the cloth is water soaked and you let the air pass. Got it? What
Yes,
happens
sir.
when this cloth is water soaked and you let the air pass? What will happen? What will happen? I let the air pass and the cloth is water soaked. What will happen?
Evaporation.
Evaporation. And what is evaporation? What will happen due to this evaporation? That was Nitisha, I guess.
No, sir. Priyamvada.
Priyamvada.
Humidity.
Let's not jump to humidity. If this evaporation takes place, what will happen next?
Temperature will decrease.
Temperature.
Yeah.
Temperature will decrease. In case my humidity is more, in my environment, in my atmosphere, what will happen to that, what do I say, that evaporation process? It will be faster or slower? If there is
Slower. Slower.
more humidity. Okay, so if I am
Slower.
using this WBT wet bulb thermometer and I place it in, say, Kolkata, and I have the same instrument and I place it in, say, Jaisalmer, okay, on any given day, what will I see? Kolkata will show me a higher WBT, or Jaisalmer will show me a higher WBT? Anyone?
So Kolkata will show higher WBT.
And why is that?
So because it is more humid, so the evaporation is less.
Okay,
Related to Jaisalmer.
the evaporation would be less. If the evaporation is less, evaporation is a endothermic reaction. It absorbs heat, right? And since evaporation is not going to take place in Kolkata, therefore the thermometer will show lesser drop in temperature, and therefore the WBT will be higher when I'm talking about in Kolkata, whereas Jaisalmer, you generally know it's a very dry state, and therefore the humidity levels are much lower, evaporation would be faster, and therefore the WBT temperature would be much lower. Clear what is WBT? Any questions till now?
No, sir.
Anyone else? Tell me any questions here?
No, sir.
Naman Pandey, it's all fine.
Yes, sir.
Amod, Amod, are you there?
Yes, sir.
Huh?
Yes. Yes, I'm there.
Okay. Let me continue then. So this WBT, it relies on the evaporative cooling effect. Now, let's just see here. Try to answer this question, give it a thought. For a given DBT, the WBT is more than the DBT, less than the DBT, or equal to the DBT?
Less than.
Less.
Less than.
Less.
Equal to?
Less
Less.
than equal to. Less than equal to.
Can it be equal?
No.
Can it be equal? Anyone? Why it can't be more than the DBT?
So if there is no
There will be
humidity,
some moisture in the air.
So we figured out one thing is, I have to do some horrible sketching now. This WBT will be more if RH is high or low. If RH is high, the WBT, the wet bulb temperature, will be higher. Yes or no?
Yes, sir.
The
Yes, sir.
DBT, it can never be, the WBT can never be more than the DBT, because evaporation is always going to take place. This evaporative cooling effect, it is always going to take place, and therefore this DBT will always be lower than, sorry, the WBT will always be lower than your DBT. So this one you must ignore. It will always be less than the DBT. This is for sure correct. Equal to DBT. In case the RH is equal to, say, 100%, what will be the WBT? What will be the WBT? Tell me. If DBT is T, small t, and RH is equal to 100%, then what will be the WBT? Come on, class, tell me.
There won't be any drop in temperature
Because there is no
evaporation taking place.
evaporation taking place, and hence there won't be any drop in temperature. So the WBT will be almost equal to the DBT. The WBT can be equal to the DBT in case RH is 100%. So this one is actually also true. Okay. Any questions till now?
Sir, it would be rather
So until
1.2.
RH 100.
One by one, please. Who was the first one talking? Hello. Which guy was
Sir,
it?
Anume.
Anume, tell me. Tell me.
Sir, I thought if RH is 100, the WBT would be rather 1.2 T. If DBT is equal to T, I thought.
Why 1.2 T?
Sir, according to a formula I studied earlier, maybe.
The WBT generally, I mean, as far as my study tells me, it doesn't exceed the DBT in any way. WBT will always be below the DBT. It will be always below the DBT. Okay, not 1.2 or anything. I mean, I'm not too sure about where did you get this formula. Why not 1.3? What happens if this RH is 100%, Anume? Let's forget this DBT and WBT. What happens if this RH is 100%? Anume? What happens if this RH is 100%? Anume, are you able to hear me? Okay, Gomti, you are saying something?
Sir, until RH is 100%, there will be no condensation.
Right.
So if it is even 0.1 more than 100, the
100%.
maximum, it will start raining or condensing.
Yes. Yes.
Okay, sir.
Okay, so it will start precipitating. Condensation would start occurring. So at 100% RH, WBT is equal to DBT. Which one out of these three is correct? Now you guys should be able to tell me directly.
First option.
Less than equal to.
You are saying less than or equal to. Or equal to. Yes. It is all in first side. Okay. To me, it is the first one, but yes, I can also take it less than or equal to, but not more than or equal to. If Anume can share where he read this 1.2 thing, I will look into it. Okay, so
Sir,
Anume,
J.
if you are able to hear me and you are giving your presence here, so just share it across.
Sir, there was a formula during our JE preparation.
Okay, so just share it, please. So at lower RH, WBT is less than the DBT because of the evaporative cooling effect. Then there is something known as the dew point temperature, DPT. So temperature where water vapor starts to condense out of the air. The temperature at which air becomes completely saturated. Above this temperature, the moisture would stay in the air, and below this temperature, moisture of course won't be able to stay in the air. Remember the first diagram we were doing. Okay, remember this diagram which we started with?
Yes, sir.
Okay, just we'll try to understand it a little more here. Now this DPT, dew point temperature. Now in this dew point temperature, I will take up a pen and are you able to understand what does this dew point temperature mean? Are you able to understand this?
Yes, sir.
So what do you understand? Who said yes?
Abhishek.
Abhishek. So what do you understand out of this?
So like saturated totally, like when there is no space, like water vapor cannot go, means humidity is like very much, we can say that
So this
very high
DPT,
humidity.
just tell me one thing, will this DPT be lower than the DBT or higher than the DBT?
This one's
DPT will it be higher than DBT? Or equal to DBT or lower than DBT?
Lower than.
DPT will be
Sir,
higher,
lower.
lower. Because we already figured out at lower volume, at this volume, the same amount of moisture which we had here it would be like this, but here it would approximately fill it up, and at this dew point temperature it won't be able to hold the moisture and the moisture would precipitate. So if dPt is approximately equal to dBt, what will happen? RH is high. If dPt is less than the dBt, the RH is low. So humidity, and so now can you tell me where do we get this humidity value? Where do we get this humidity value?
Sir, some operations on DBT and WBT.
I told you about some graph, about some chart. Tell me the name.
Psychometric chart.
Psychrometric chart, not psychometric. It's not a psycho chart. It looks like psycho, but psychrometric chart. We'll look into it probably in the next to next class. So humidity is measured with this wet bulb, dry bulb hygrometer. It can be a sling one. Now you see this instrument. Okay, you have the handle. You have in this case this water soaked wet wick, and you have the dry bulb thermometer here. These two. Now you hold this handle and start rotating like a sling this entire setup, and you will find out how much is the temperature difference between the two. The difference in temperature between the wet bulb thermometer and the dry bulb thermometer is known as the depression point. You might check into it. I believe it is known as the depression point. So that is the depression between, due to this available humidity, moisture, evaporation, how much is the temperature difference, that is known as the depression point. So you have one wet bulb and one dry bulb, evaporation from, and this one is the sling option, but when you're using it in the Stevenson screen, of course you're not going to rotate it like a sling every minute or every second. You keep it inside the screen, you let the air flow. If it's on a hot day, let it flow through the screen, because you have louvers in your screen, we saw it, and that way you directly can read the temperatures without going through this physical process of slinging the entire setup.
So why do we have to rotate?
So that you make the air flow, so that you hasten this evaporation process. Okay.
Sir, but wouldn't that affect the temperature?
See, it's the dBt. You're right. This dry bulb temperature, which you are seeing, that is not going to be affected much, because uh, just give me a minute.
Okay, sir.
Hello. Good morning, sir. सर हाँ सर मैंने किया कि more than 8 years after masters. हाँ ओवर लिखा है सर. हाँ जी आपके बात नहीं है, अगर वही मैंने इसलिए एमआर को भी मेंशन करके एमआर के एमटेक 2009 का है. हाँ सर. हाँ सर. सर अभी आप डिपार्टमेंट में रहेंगे? हाँ तो मैं क्या 12 बजे के अराउंड आऊँ सर? ठीक, मैं कॉल करके आ रहा हूँ। थैंक यू। ओके, shall we continue?
Yes, sir.
Yes, sir.
So if we don't rotate it, we are not exactly accelerating the airflow. I mean, we are not actually letting this air flow around the wet bulb, and that much amount of airflow is not going to affect the temperature directly, and hence you can, don't need to bother much about how much this airflow is going to affect the DPT.
Okay, sir.
Okay. Anyways, also you have this screen option in which you do the same thing, but you let it settle and let the entire process continue. You have this temperature depression. That is the difference between the DBT and the WBT.
So where is the depression point, sir? In the previous example.
Where is the depression point? Here is the depression point. Okay.
So, okay.
Yes.
So depression point lies on the bulb which is at a lower height.
It doesn't lie, it is the difference. The difference, we figured out DBT is always going to be greater than the WBT. In general, it is going to be, right? And we also, the difference between the DBT and the WBT.
Okay, sir.
Okay. There is one online link which you can try, this omnicalculatorphysics.wetbulb, which can give you the respective WBT if you give the DBT and the relative humidity. Okay, you can check this website. Let's see. So here you can do a quick calculation to see if the is this Omni calculator setup visible to you guys? Right?
Yes, sir.
Yes, sir.
Okay. So here you can enter the temperature value. Say for example, I have 46 degrees Celsius and the relative humidity I say 50%. So WBT in this case is 36. So what you will be feeling on your body, if you're in shade, you will be feeling 36 degrees Celsius. Got it? Are we clear
Sir, we
here?
can figure it out here. Sir, we can figure it out here whether the wet bulb or dry bulb is same or not, sir, if we write relative humidity 100.
100. I think it doesn't take 100, it takes 99. Okay, it says 46.015. Okay, Anume. That's Anume, right? Or Aman Singh?
Sir, Aman.
Aman. Okay, so this is a little bit higher. Just slightly higher. It shows. I'll have to check it out,
Yes, sir.
whether it will be higher or lower. I'll check it out. Okay, but it is approximately equal. I should rather not say equal, I
Yes, sir.
should rather say approximately equal. Okay, I will update the slides later. But what I'm trying to say here, say if it is 20 degrees, 20% is the relative humidity, the wet bulb temperature is 26 degrees Celsius, you would feel normally comfortable. 23 degrees Celsius is somewhere we are comfortable, right? 23, 24 degrees Celsius. We
Yes, sir.
might feel comfortable, but something else would also take place is your body would be losing moisture without you figuring it out. When you sweat, you're actually able to figure out that your body is losing moisture. It might not be comfortable, but you actually figure out that you're losing moisture from your body. But in this case, when your relative humidity is so low, you might feel comfortable. People who are in these dry areas, desert areas, they might not feel that much irritated with this temperature of this 46 degrees Celsius. The comfort level won't be that much hampered, but otherwise the body is actually losing a lot of moisture, and that could be an issue. Okay. So you see the dry bulb temperature and humidity, there is a certain relationship. I'll look into these graphs in detail later. The dry bulb and the dew point. Has any of you downloaded that climate consultant software? Climate consultant? Hello? Aman?
No,
Yes, sir.
sir.
Have you used it?
No, sir, I have not used yet.
Okay, just try to get in touch with it, because your next assignment, which I'll give tomorrow, will be in relation to that software. So try to get a hang of it. So this precipitation is another climatic element. So humidity, yes.
Sir, please repeat what we need to do.
I haven't given the assignment yet, but you try to get your hands on the software climate and consultant. Assignment to kal milega.
Okay,
Okay.
sir.
Okay, you'll get the assignment today. Today you'll be getting a class test, which you need to submit tomorrow. So precipitation, it encompasses all forms of water, like rain, hail, snow, dew, frost, anything. So something you can understand, this dew point or dew is somewhere linked. Is the screen visible to you guys?
Yes, sir.
Clear? Audio is clear?
Yes, sir.
Yes, sir.
I got a notification that the network quality is not good. So you check out the maximum rainfall for any 24-hour period. It is a useful guide for prediction of flooding. And maximum hourly rainfall intensity is useful for the design of surface drainage. The total amount of precipitation is measured in rain gauges and expressed in millimeters per unit time. That is precipitation. You need to look into it for specifically the drainage, the water collection. If you're talking about a sustainable building, how you can harvest that rainwater within your building to use it for different purposes. So that is where your precipitation comes into picture. Might not be a lot is discussed by me now, but yes, it is an important part. Sky conditions. So it is described in in terms of presence or absence of clouds. How much cloud is present and necessary specifically for the design of daylighting. So here you can see what is the average cloud coverage. What is the higher side and what is the lower side? Recorded low, recorded high, and that is the the range. Might not be much, but yes, we'll be looking into this cloud coverage, the sky conditions when you discuss about daylighting. It's an important part when you talk about any climate responsive building.
So while calculating sky cover, are there certain boundaries of sky? Like this is the area we should see for the cloud coverage.
Yes, but you don't need to calculate, you don't need to collect the primary data. You actually should be focusing on the secondary data which is available from the IMD or any meteorological department. Okay, so don't have to bother about collecting these data on your own in most of these cases. But
Okay.
yes, within a certain boundary conditions, you have to collect the data. Solar radiation, it provides information about how much of the sun's energy strikes a location on the Earth's surface during a particular time period, generally represented as kilowatt hour per meter square. You measure it using a pyranometer on an unobstructed horizontal surface. And the tilt of the Earth's axis is more significant factor in determining the amount of sunlight striking the Earth at a particular location. The solar radiation that reaches the Earth's surface is partly reflected and partly absorbed, depending on the reflectivity of the surface. This reflectivity of the surface is also termed using albedo. So albedo maximum value, I'll change the color. Albedo max
1.
1. Which type of surface will have max value?
Shiny.
Huh?
Mirror.
Mirror or a white surface. Okay.
Sir, mirror or?
A white,
Okay,
pure
sir.
white surface. Minimum
Black, uneven,
black
rough.
and minimum value. Again, I won't say absolutely. For your understanding, I will say tends to 1 and tends to 0. Okay, for our understanding, to be a little bit more precise, it tends towards 0 or tends towards 1. Nothing is absolute, as you might be aware of. So a black surface will have an albedo towards 0, like a black road. A black top road will have a lower reflectivity, right? More would be absorbed.
So what kind of earth or ground would result in albedo maximum, like tending to 1? Earth.
Or you have to think, if you talk about, how do I say, you paint the surface white. That is what I can suggest.
So how about, like, is it dependent upon soil? Whatever is sand or soil more
Sand,
for
of
solar
course,
protection?
soil, of course. Just think about it in this way. When we spoke about the Stevenson screen, you remember where it was placed in the image?
Yes, away from the urban areas, more in a
And
isolated
what type of
greenery.
ground surface was there? Can anyone tell me? What type of ground surface was there?
Grass.
Grass.
Grass, which has albedo of something like 0.2 or 0.4. Albedo depends on the type of surface and What else will this albedo depend on?
Color of surface.
Color of the surface, the texture of the surface, and the type of the surface. Okay. And that is the instrument, the pyranometer, which is useful specifically for determining the layout of PV panels. Something else is the wind. Wind is the movement of air mass caused by the differences in atmospheric pressure related to land, water, and air temperature gradients, normally measured at 10 meters above the ground in open country. But in case there are built-up areas, you try to measure it in the higher levels. That is the wind gradient. So parameters which characterize wind are the speed, the direction, and the frequency. These three parameters are necessary when you're talking about the wind. So velocities near the ground are much lower than the free wind speed. So velocities in meters per second are recorded into 8 or 16 directions. Into multiple directions, you try to take in the measurement. Here, this is just the velocity range, and I believe it is in meters per second. It is in meters per second. If you look at this corner, here it is in meters per second. The average, the higher, and the lower level, the annual. But this data is not sufficient for our work. What is required for our work is to understand the prevailing wind conditions from this type of wind rows. The schematic representation of the three parameters is given by this wind rows. Can you read this graph for me? Whatever is visible, can anyone read this diagram for me? Which is the prevailing wind direction?
So southwest.
Southwest. Or I would say west, southwest. It is more tending towards the west direction. Okay. And
Yes, sir.
what is the speed? Here at the upper corner, you can see the
Something
hours.
more than 44.
Sir, 42, 45.
On an average,
So we can't read that.
the white ones, right? Forget
Yes,
the white ones. But
144, maybe, I don't know.
see, what you can see here is for a maximum time, you have a wind speed of approximately 20 kilometers per hour for the maximum amount of time. For a fairly low amount of time, like less than 44 hours within the entire year, this is the annual value, you are having a wind speed of, how much is this? 40 kmph plus. Can you understand that? Yes?
So
No.
that gradation scale is hours, and over this y-axis we have velocities.
The radial ones are showing the velocities. Okay. Got it? Here, this diagram, this graph, this legend is showing you the number of hours. Or rather, I would say the frequency. Clear? Priyamvada?
Yes, sir.
Naman?
Yes, sir.
Okay. Now, what can you tell me about the predominant wind direction? Gomti said initially by looking at this diagram it is towards the southwest, but more towards the west side, right, Gomti?
Yes, sir.
Okay, now after understanding this part, the legends and whatever scale is being shown, can you tell me what is the predominant wind direction?
West.
West. Who said that? Who was that?
Sir, Aman.
Man. Predominantly, it is towards the west. How many hours are there in a year? Can you tell me? How many hours are there in a year?
8760.
8760. Out of that, for less than 44 hours within the entire year, my wind velocity and direction are in this zone, right? Majorly, this whiter part, if you try to check, is in this direction, and so it is in the west direction. We need to focus on, west means east to west. We need to focus on when you're talking about the airflow, when if you try to incorporate the natural ventilation concept into your building. Okay, so you need to identify the prevailing wind conditions, the pattern, and the calm periods. So those were the climatic elements. Got it till now?
Yes,
We
sir.
discussed the temperature, humidity, precipitation, sky cover, solar radiation, and wind. Now we will be looking at how these climatic elements come into picture when you talk about the tropical climates. What is this tropical climate? We discussed it, I think, 2-3 classes back. Tropical climate, what is it? Anume, would you like to say?
Sir, hot and wet.
Hot and dry is tropical.
The climate around beaches are generally called tropical climates.
Not
as
necessarily. Not necessarily. Can you tell me? I think we discussed it about 2 classes back.
Sir, hot and wet climate near the tropics.
Which region is this tropics?
Sir, Tropic of Cancer and Tropic of Capricorn.
Yes, the Tropic of Cancer and the Capricorn, 23.5 degrees upper and lower. That is which? That is what comprises this tropics, right? Who said this
Yes, sir.
last answer? Who said this last answer?
Aman sir.
Aman. Anume, you are not in the class or not interested to talk in the class? Same, I think, is the problem with Hemant. So the tropical climates we discussed, it is in between these two regions, the Tropic of Cancer and the Tropic of Capricorn. In Hindi, I think it is the Karkvrit and the Makarvrit. I studied geography in Hindi. Now I have forgotten most of it. Okay, and within this span is where is the tropical climate. Not basically with the coastal regions. Coastal regions, if you talk about in Northern America, say in US and India, there would be a bit of difference in the climate conditions. Because India falls in the tropics and that area is somewhere in the, unable to recall now, it's in a different zone. So climate would be a bit different. Tropical climate, there is a certain other
Sir,
thing.
continental.
Continental, thank you. Thank you. Somebody has been taking notes, it seems. So that is where you have these variations, and tropical climates, the temperatures are generally on the warmer side. Rarely the temperature falls below a certain level, like 15 degrees Celsius. So average temperature is more than 18 degrees Celsius in the tropical areas. Annual precipitation is often abundant. And normally only two seasons are there in tropical climate, a wet season and a dry season. There is a much less chance of the winters. So classification is generally done on the basis of air temperature, humidity, are these two criteria which helps in understanding the classification. And that is where, while discussing the elements, I try to focus a lot on the air temperature, humidity, because these are the two criteria which comes into picture a lot when you talk about any climate responsive design. The main criterion is what extremes of these two factors are likely to cause discomfort. So there are three major classifications. You have the warm humid climate, hot dry desert climate, and composite or monsoon climate. India is divided into 5 regions. Including these 3, you have 2 more. There is a temperate climate and the cold climate. Specifically near the Himalayas, you have this cold climate. I mean, cold climate, of course, you have other options also due to different varying altitudes as well. This is our India. And you can figure out majority of our country falls in the warm humid and the composite zone. Partially you have in the cold regions. And can you tell me which zone is, which place is this? Nitisha will be able to tell me.
Mount Abu.
Near Mount Abu, Dilwara temples. There are certain such areas which have these cold climates. This one, can you tell me which one is it? Where is it? What place?
Sir, Kodaikanal.
Kodaikanal. Have you been there?
Yes, sir.
It's a nice place, Kodaikanal. Cold climate. What are these pink ones? Temperate. Which location will this be?
Sir, Ooty.
So this is Bangalore.
Yes, it is near Bangalore. Kurg, Bangalore, in that area. That is the zone. I mean, I actually colored it a little too much. Kodaikanal and Bangalore, Kurg, it is all in this same region almost. Okay. A detailed diagram you can also find in this National NBC, or you can also refer ECBC, Energy Conservation Building Code 2017 or 2007 version. You can check it out there. So talking about hot, looking into these 5 criteria for our understanding. The topography in hot and dry is flat, sandy and rocky. Soil is usually dry and dusty. You can see here hot and dry. Which states is it covering up? Mostly Rajasthan, Gujarat and Maharashtra. This hot and dry in Maharashtra, which areas are these? You find most of these farmer suicides and stuff happens in this area. Amod, where are you from?
Sir, Thane, Mumbai. Near
Thane.
Mumbai.
Yeah, I understand. Anyone else is from Maharashtra in this region? or
So
Gujarat.
those regions are Aurangabad, Latur, Nanded.
Yes, nearby that area. And some other places name I cannot recall. Even if there are floods in Mumbai and Pune, these places very rarely get good amount of rain. Annual rainfall is less than 500 mm. So hot and dry. So the topography is generally dusty, sparse vegetation, and very less groundwater and surface water sources. And the temperature, the radiation is very high radiation levels, and ground gets heated up faster in the day. Summer temperature reaches to around 45 degrees Celsius. I think last class when we were discussing about the temperatures of one location, I think it was of Jaisalmer, the temperatures were much on the higher side. The summer nights are much cooler, rather comfortable. Winters, the temperature reaches somewhere to around 0 degrees Celsius. So there is a high diurnal temperature range. What is this diurnal temperature? What is this diurnal temperature?
Sir, extremely high and extremely low
What?
temperature.
During the year?
Sir, maybe during the day also in cases
So
like
the
a
same
desert.
day, maximum and minimum
Same
temperature.
day. Okay, look at the summer nights. You are seeing 20 to 30 degrees Celsius, and summer days you are seeing 40 to 45. There is a difference of almost 20, 15 to 20 degrees Celsius difference. What will be its implication on your design as an architect? Can you tell me?
Sir, using of materials which do not expand and contract easily, because it will lead to cracks in the walls or some, in the building.
Okay.
Because expansion and contraction regularly may affect.
The structure of the material. Who is this?
Yes, sir.
No, who is
Sir,
this?
Aman.
Aman. Okay, that difference. I mean, you have to take up some material which can actually withstand these temperature differences, this diurnal temperature difference. And that is why most of the time earlier you would find that the buildings in the Rajasthan areas, Gujarat, and most of these zones, they had to use stones which could take in this diurnal temperature variation. We'll look into these strategies gradually. So humidity and precipitation, very low humidity levels with no vegetation and water resources, and low rainfall less than 500 mm annually in the region. Winds, hot winds and sandstorm during the day. Winds carry dust and sand and often develop into sandstorms. I mean, and because of these sandstorms, you would find that there are situations of haze and the radiation is highly diffused during the summer months. You won't be able to see the sun due to these sandstorms. Clear sky condition, you get more radiation and causes glare, and heat collected by the ground during the day is radiated due to the clear night skies, and hence the nights are generally cooler. The best part about the land, if it gets heated up faster, it gets cooler also at a faster rate. And these hot air, cold air, it leads to air flow, wind movement, so the nights are generally more pleasant in most of these places.
So
That is
nights are cooler because of the property of soil, sand, I mean.
soil, sand, the ground
Land breeze,
conditions.
sea breeze.
You won't find this sea breeze when you talk about, you know, say Jaisalmer. Where would you find the sea breeze? Tell me.
Sir,
Okay,
near the coastal regions.
coastal regions are a different thing altogether. We'll be looking into this warm, humid, but in hot and dry, when this, land gets heated up, and this heat gets released in the evening. Air being lighter, it rises upwards in the atmosphere, and that brings in the cold air to fill up that void that is gradually being created, and hence you have this airflow. And those who have stayed in these Rajasthan areas, they will be able to tell you better, except that one blue spot. Most of Rajasthan is on the hot and dry region, because I have stayed and I have seen it. Okay, this one is the data for a hot and dry region. You can see how much is the variation in the how much is the variation in these temperatures. Now this is the average one, which is the average daily temperature and average design high and design low. Okay. Also, you can figure out what is the relative humidity, the average daily temperature, humidity. This red line showed on the right-hand axis, and the sky coverage. The sky coverage is always on an average below 50%, the sky cover. And relative humidity is also below how much? 70% on an average during the entire year. But the temperature rises on a very high level. The total horizontal radiation, I think this orange line, it's visible to all of you guys, right? The color contrast and all. So what you can see here, the recorded high radiations are 1230 watt hours per square meter. It's on the higher level most of the year. The diffuse radiation is generally lower, the black line, whereas the wind speed, again look at the right side, the wind speed is also less than 5 meters per second on an average for the entire year. Let's not look at the direction, because that is what we'll be concerned with when we talk about individual projects. I think it is for Jaisalmer. Look at the elevation, it is 242 meters above mean sea level, but still it is in one of the hot and dry regions. The data has been developed by ISRE, Indian Society for Heating, Refrigeration and Air Conditioning. Rest you have to figure it out. Okay, so you have to, the design strategies would include controlling solar radiation, controlling the hot summer winds, restricting heat gains and controlling ventilation pattern, designing for water bodies to add moisture to the dry air and thereby try to lower the temperature and the heat emitted through surrounding features and ground. Warm and humid. Topography, basically the coastal part, hence the proximity to the water. We saw it is mostly around the coastal part in the southern, western, southern and eastern side of the country. High humidity levels give scope for abundant vegetation. The solar radiation, basically you have diffuse radiation is more due to the sky cover, and summer temperatures up to 35 degrees Celsius, summer nights are around 30 degrees Celsius, almost the same. So in this case, what did you tell me? The diurnal temperature difference is high or low?
Low.
Low. It is much low, like 5 degrees or almost nil. So very high humidity levels in the range of 75 to 90%. So here the WBT, will it be near to the DBT?
Yes,
Yes.
sir.
The WBT will be near the DBT. Aman, we are right here. Aman?
Yes, sir.
Where is Naman Pandey today? Haven't heard from him.
Yes, sir.
Okay, just try to be interactive in the class. So heavy rainfall, so you have 200 to 500 mm annual rainfall in these regions. So winds, typically low, calm periods are frequent, strong winds during the rain squalls. You find the cyclones, heavy rains. There is something also you'll come across when you talk about precipitation and rain is something known as driving rain. Can you tell me what do you understand by driving rain? Rain, I guess all of us can understand. What is driving rain? What is driving rain? Can anyone tell me?
So which initiates monsoon winds?
शायद wind से affected types.
Yes?
Wind से मतलब कुछ affected होगा या फिर ऐसा कुछ.
The rain which is affected by this wind. If there is wind flow, you have this rain which is, instead of falling vertically downward, it is forced towards your indoors. That is the driving rain. Okay. So wind basically from one or two prevailing directions with speed from very low to very high. The windrows diagram we saw earlier, that was for Mumbai. So there are one or two prevailing directions and very low wind speed, less than 5 meters per second. Sometimes you have wind speeds in excess of 40 meters per second. And the sky conditions, mostly cloudy, which gets in diffuse solar radiation. Generally on a given day within the year, you have 60 to 90% cloud cover. Okay, again, you can refer this diagram. You can see here this red line, which I have encircled in red to create more confusion. The relative humidity is over 70% on an average. The sky cover, specifically during certain times during the year, this zone, you can see the sky cover is more than 50% per month on an average. The dry bulb temperature, these blue lines, and the wet bulb temperature are rather close. There is not much of a gap. Even WBT is very close to the DPT, dew point temperature. Whereas I think there must have been a huge gap in this case. Can you observe that? Can you observe that the DBT and the WBT, the gap, the temperature, the depression temperature is high in these cases, whereas here the gap is much lower. Are you clear on that?
Yes.
Got it? I think it's very much visible. So that is for Vishakhapatnam. That was for Vishakhapatnam, coastal region. Elevation is 3 meters over the mean sea level. The ventilation or accessibility to wind, cross ventilation to promote heat loss. Here in these places you have higher humidity, you have to promote the movement of this humidity, and therefore you have to promote cross ventilation in such places. Cross ventilation, if you try to provide in case of hot and dry regions, it is going to be a bit of a problem. You won't expect cross ventilation during the day. The winds are warm. You wouldn't like the wind to be brought inside your house. So reduce heat gains by providing shading, provision of quick drainage of water during monsoon spells, and prohibit mold, weed, algal growth of mosquitoes, and any of these, unnecessary elements, because it's always warm and humid. Mosquitoes are like prevalent in these places. You have composite climate. So variable landscape, seasonal vegetation, covers almost parts of the central area. Anything away from the coast and away from the dry regions, the hot and dry areas, is mostly composite climate. Solar radiation and temperature, it is very high in summers, intensity is lower in monsoons. Summer temperatures and winter temperatures, here again the temperature, the diurnal temperature variation is like 10 degrees Celsius, whereas in hot and dry we figured out it is 10 degrees, 15 degrees or more on an average. Humidity and precipitation, humidity levels are moderate, 55 to 95%, lower humidity otherwise most of the year, 20 to 55%, and rainfall, of course, it is much lower than the warm humid areas, but it is considerably higher than what we felt with the hot and dry regions. Winds, summers are hot and dusty, monsoon winds are fairly strong and steady. Look at this diagram here, you can find that there is a big difference between the DBT and the WBT in the month of May. It is also related with the red line which shows the relative humidity. Can you guys observe here?
Yes, sir.
Here if you can see at this level, the WBT is quite close to the DBT. Not much of a difference because you have higher level of moisture, relative humidity. Clear? Okay. Similarly, you can refer the rest of the graph. Nothing special. Temperate or moderate climate you won't find in many places across the country. Some places like Ratnagiri, Bangalore, you might find this moderate climate. Abhishek Chaudhary, anything you'd like to
No, sir,
show?
sorry, it was by
Okay,
mistake.
fine, no issues. Happens with almost everyone. So I'll deny then. Okay, so topography in this temperate or moderate climate, the weather across the year is generally pleasant. In these regions, but then there are issues of, the sky conditions, generally clear sky, but mostly the temperatures are, how do I say? I mean, there's not much of a difference between the summers and the winters. See, the summer night, day, there's not much of a difference. As you can see here, this I believe is for Bangalore. So you have to provide adequate insulation to reduce heat loss and maximize cross ventilation in the monsoons to cater to high humidity levels. Cold climate, we might not be designing for cold climate throughout your entire year. If you are in Hamirpur, you would be doing it, but not here. The region is mountainous, has little vegetation, and is considered to be cold desert. Desert is a place where nothing grows. That is where you have this cold desert and the conventional desert like Thar. So you can see that the temperature variation during the summers and the winters is huge. In winters, the temperature goes negative as well. In case the temperature goes negative, there is a tendency that your internal heat from the building will be, conducted towards the outer areas, and your indoors will become cold, and hence you have to take precaution of giving proper insulation to your building. Rainfall less than 200 mm in a year, that gap, I don't know. The sky is fairly clear throughout the year with a cloud cover of less than 50%. Okay. This one is from Pagri in China. I think it is a part of Tibet. Now this is the class test for you guys, which I'll be just showing you. You have these 4 climatic details, climatic data at your disposal, and you are required to identify the relevant climatic zone and give proper justification. What we will be evaluating is your reasoning to arrive at a conclusive answer. So if you directly say that it's a warm humid climate, as you can see here in the grading section, you won't be awarded much of a marks. But justify
Sir, not audible.
Hello.
Hello, sir.
Sir, not audible.
क्लास डिसमिस हो गया क्या?
अभी क्लास खत्म क्या?
तो है ही नहीं.
डिसमिस कर दें?
Hello.
Not audible. Not audible.
हेलो.
Not audible.
सर आप हैंग हो गए थे.
Am I audible now?
Hello.
Not audible.
Not
Not
audible?
audible, sir.
Plus
Audible,
one.
sir.
Audible, right? My internet connection just left me. Okay. Hmm. So you're talking about this small assignment that you have to work on. You have to submit it by 2 p.m. tomorrow, and you have to submit it on the MS Teams. I'll be uploading the slides right now, and you have to submit it there. You have to justify why you are reaching to a certain conclusion. For example, if you say that this one is for a hot and humid, a warm and humid climate, you have to justify on what basis you are saying that it is on hot and humid and not a cold climate zone. Okay. Are we clear with this? Are we clear?
Yes.
Don't be so disheartened when some assignment comes up. These assignments are not exactly for, creating problems with you. This is for to help you understand what you are studying. It goes with for almost all subjects. And this will contribute to your midterm evaluation as well. So if I'm able to take sufficient number of class tests, then during the midterms you will be free from my side.
Okay, sir.
So that way I won't be bothering you towards the midterms, and I'll try to practice this during your entire 4-5 year program. Okay. Fine. Any questions till now?
No, sir.
Hey, Hemant, any questions?
No, sir.
Was your question clarified which you asked on my WhatsApp? Hemant?
Sir, मैंने question पूछा था.
Hemant, am I audible?
Yes, sir.
Was your question clarified that you asked on WhatsApp?
Sir, I didn't ask any question.
You didn't ask, then who asked? Where should you make the section from? Whosoever it is, just don't ask some poor questions just for the sake of asking. I found many of you have not submitted the assignment on this MS Teams. I don't know how will I be able to grade you guys there. Okay. So with that, I believe I will end the class for today.
Okay, sir.
Okay. Have a nice
sir.
day. Enjoy your week. And tomorrow we'll meet at 2 o'clock. And try to submit, or I would say submit your assignments before 2 o'clock. Because we have another assignment coming up for the coming 1 or 2 weeks. So before that, try to submit this class test. ठीक है?
Yes, sir.
Sahil, everything is fine?
Yes, sir.
No interaction from you today. What happened?
Nothing, sir.
हाँ, क्या हुआ साहिल?
कुछ नहीं, sir.
तुषार, things are all fine?
Yes, sir.
क्लास में कुछ पूछा ही नहीं आज आपने?
कोई डाउट ही नहीं आया.
Doubt नहीं आया? So everything is clear.
Yes sir.
सर
What
असाइनमेंट में एग्जैक्टली क्या करना है हमें?
you have to say that why this thing is in this location, why this data which I am showing you. Like for example, we discussed it during the class that this is for a temperate or moderate climate. We have certain justification based on the earlier slide which told you that these are the topography, temperature, precipitations. You have to do some self-study also to understand as to why these are your locations that have been mentioned. Also, one more thing I would just show you is the last slide. These are the resources. These are the books you can study, and for your convenience I'll try to upload this in your class notes. Next class we'll be looking at site climate. Okay, so I'll try to upload these names of these books for your reference.
Thank you, sir.
Thank you, and I believe you have got the link for this online digital library that all faculties have floated for you guys.
Yes, sir.
You can check it out there. Probably the first book you won't be able to find there, but rest of the books may be there. The first book you can purchase, it is an Indian edition book, doesn't cost more than 400 or 500 bucks. But it's rather helpful for our class and some design inputs if you try to take for sustainable design in future. The first book you can buy, it would be advisable. Manual of Tropical Housing and Building Design. You have to just tell us why this data is pertaining to a certain climatic zone. This is the book I am talking about. If you can see the cover, Manual of Tropical Housing, Königsberger. A very good handy book for climatology. Okay. ठीक है? Can I sign out now?
Yes.
Yes, sir.
Thank you, sir.
Ritisha, any questions more? Any more questions?
No, sir.
Ashish Prasad, all fine?
Yes, sir.
ठीक है, then see you. I'll upload the assignment and try to submit tomorrow.
Bye, bye, sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
नितिशा सबमिट कर दिया क्या रेणुका का?
हाँ
रेणुका का सबने सबमिट कर दिया.